with microservices or rather virtualization, right? Any context or any idea what virtualization is, anyone can take that up. Whoever has worked on it or whoever hasn't worked on it. What do you understand by virtualization and when do we use it and why do we use it? What is virtualization?
So basically, it's a single server which can act as a like a multiple VMs,
Mm-hmm.
and each one can have their own like OS, and it's basically a environment creation basically using a single resource.
Okay. Anyone else? Cool. Okay. So, Sarang, what you just said, right? At a high level, that is exactly what virtualization is. We'll come to the internal implementation of it. So, think of this particular machine as a Mac machine or a Windows machine, right? This is what we typically use in day. A Mac can have its own CPU, its own GPU, its own NPU. It's not really there, but think in terms of processors where it is required for AI ML activities, right? So NPU is there. Then it'll have a RAM and it'll have a storage for ROM and all. So this is a typical physical hardware that you will have. Similarly, for Windows, you might see Intel, you might see RAM, you might see ROM, right? That's something you should understand. So in terms of physical capabilities, this machine will be able to spin up activities or processes or threads to the maximum limit it can support based on RAM, based on the processing unit that it supports and based on the storage that it has, right? So let's say storage is typically allocated as a database, right? So this is where you're going to write and store. RAM is something which is a fast or in cache memory, which is where your processes will technically run. So you can have, let's say, your Xcode will run here, your Android Studio will run here, right? So it will consume some memory in the background when it is accomplishing a task or running a task, right? So that is typically where your RAM gets exhausted. Processing power or processors technically will be your CPUs, right? It will define whether it has one core, two core, or three core, right? So depending on the number of cores you have, you can spin up process. So if I say I have one core machine, I can only run one process on that machine at a time. If it is Intel, they have something called as multi-threading implemented. So it's one core can technically run two threads only in case of Intel or AMD based architecture, right? So they can. So they have their something called as multi-threading. I think they name it something differently, but each core can run two threads individually. That means two processes can run parallelly. So you can technically run Android Studio also, and you can run Xcode also if it is a one core machine. In case of Mac, the multi-threading is not technically applied, so you will be able to run one thread or one process only. So this is your natural extension of a physical machine that you have, right? So when you want to, let's say, test something, so if you have to spin up Postman, that will technically consume some RAM, that will technically consume some ROM because it has to be installed on application, and then it will consume some processing unit power also, right? How do you use it? When do we use it? That probably will come to the next session when we discover more about performance and all. So this is most of your use case in hardware or physical capabilities. What if I have only Mac or only Windows? That's a problem that we face today. But our users are typically in multiple regions and they use different sort of devices also. So somebody can be using Mac, somebody can be using Windows, somebody can be using Linux, right? Or somebody can be using Android OS as well or Chrome as whatever they call it. So these are your typical variations of a single entity-based application architecture support that there is, right? So what do we do in that case? Since we don't have the flexibility, we can't go about buying this, buying this, buying this, buying this. So it becomes a challenge. So we end up emulating all of this activity. What we do is, depending on the machine we have, we go about and then we create instead of physical versions, we create software based versions of it and we call it virtual software, right? So if I had a Mac, I will end up running a virtual image, right? maybe for Windows, maybe for Chrome OS, right? And this way, I will have an extension within a single entity to test all of this by myself and one for Linux, right? So this is what typically virtualization is. And when you do it, basically you are emulating the OS at a virtual layer. You don't have physical capabilities. So think of it like if I had this big of a box which has all the CPUs and NPUs and all. In that box, I will create smaller sub boxes and I will say, boss, this is your Windows, this is your Chrome, and this is your Linux. So it is a limited set of capabilities within my main processing unit, my OS level. I dedicate different subcomponents to it and say that, boss, my single machine is capable of running independent systems. And this is typically virtualization. Now, how does it matter? And